Good morning, sir. My name is Heng Wen Sen. We are from Group 26 and our title is Smart Traffic Monitoring System. I'll be talking about the background of Smart Monitoring System. Smart Traffic Monitoring System is an idea of managing the traffic conditions by applying the modern ICT technology to increase effectiveness of managing and solving road congestion problems. Next, there are plenty of technologies that can be applied in the traffic monitoring scenarios to enhance the efficiency and to reduce the occurrence of traffic congestions such as sensors, IoT camera, smart traffic light, and cloud solutions. With the smart traffic management system, it applies many IoT cameras and IoT solutions that can be used for monitoring the condition of the road from time to time, as IoT devices are able to connect easily, widely, and without restrictions. Therefore, this system can bring a lot of advantages to the relevant authorities such as traffic police. With the advantages, the traffic police will not need to go on site to know the situation of the traffic, and they can implement their solutions for traffic congestion more efficiently if congestion occurs with the results given by the system. Furthermore, the system will also alert the traffic police if traffic congestion happens in case they mislook or unalerted with it. Thus, the traffic police can ensure that they are able to act in time to solve the traffic congestion efficiently. That's all from me. Thank you.
Hi, my name is Wei Xuan. Nowadays, traffic lights have become an important system in maintaining traffic orders and providing more safety to road users. The concept of traffic monitoring dates back to the early days where traffic lights were only used for railroads in 1860s. It was aimed to reduce the workload of traffic police. Slowly, as there is just too much road users in the 1900s, the first traffic light was introduced. As technologies improve, more and more solutions for traffic light have been introduced. The one which is most common is by using inductive loop sensors, as shown in the picture over here. The sensor is embedded in the pavement to indicate presence of vehicle and send signal to the traffic light. Besides, there are also different sensors which includes infrared sensors, microwave sensors. The most advanced system is through video sensors, paired with AI technologies, which was introduced in cities such as Pittsburgh and was proven that the wait time at intersection was reduced at 40%. Next is future trend of smart traffic monitoring system. With the mass availability of cloud solutions, it allows developers to connect multiple IoT devices and sensors to develop a better traffic monitoring system. Other than that, we could also see more drones being used as many industries have already started using drones to do their work more effectively. Moreover, with the stronger computational power the cloud offers, developers could also implement stronger, faster, and more accurate AIs to recognize patterns in traffic. Besides, we could also see smart traffic signs being introduced sooner or later where it can detect traffic violations with IoT sensors and automatically find the road users. Traffic congestion has been a very common problem nowadays due to the fact that there are just too many road users. Congestion normally occurs in highly populated locations, such as workplace area, for example central Kuala Lumpur, especially during working hours. People tend to be in traffic for hours before they could get to or off their workplace. Other than that, it is because of the traffic lights we use are pre-programmed to change lights after a certain amount of time, which is very inconsistent in real-life situation, where traffic will not be as busy compared to a certain period of time frame and given situation. These problems have caused heavy workload for traffic police as they constantly needed to go to busy intersection to solve traffic congestion. Therefore, our objective in this assignment is to develop a system that implements cloud solutions to help solve the congestion in traffic and have better control over the traffic. With the help of AWS platform services and IoT devices and also artificial intelligence, the system will make use of smart cameras to capture images of the junction from time to time and make changes to the smart traffic light. The smart camera will upload the taken image to the cloud to perform recognition, and if the system recognizes there is congestion happening, it will automatically make changes to the green light duration for that junction accordingly. Besides, it will also notify agencies that changes have been made in order to reduce their workload. That's all from me. Thank you.
Figure here shows the architecture diagram of the smart traffic monitoring system. The system is mostly created using Amazon Web Services. First of all, the IoT camera is used to collect the real-time traffic and the street photographs, while the IoT sensor is used to further confirm whether the road is full of vehicles or not. After that, the images and data will be passed to the IoT core and stored inside the S3 bucket. The Lambda function was created to retrieve the image from the S3 bucket and analyze them in the recognition. If the images was recognized as a traffic jam, it will generate a notification to the police station to take action. Besides, the result obtained can be viewed as a form of log through the CloudWatch. Lastly, the processor's data will be stored inside the DynamoDB.
Hi, my name is Tan Zhong Wei and my student ID is 19ACB06234. Now I would like to present about the study of different IoT platforms. The following section will introduce the feature of AWS IoT, Google Cloud IoT, and Azure IoT. The first IoT platform that we discuss here is the Amazon Web Services IoT. AWS is the most popular cloud platform in the market, with about 31% of the cloud service market share. Besides, AWS IoT provides users with 3 types of IoT service, including device software, control service, and analytics service. The device software service include the free RTOS, AWS IoT Expert Link, and AWS IoT Green Glass. And this service designed for connect the IoT device and operate them at the edge. Control service is enable user to secure, control, and manage IoT device from the cloud, such as the AWS IoT Core. An analytics service for the IoT are work with IoT data faster to extract value from the data. For example, the service including AWS IoT Event and AWS IoT Analytics. Next, a few key features of AWS IoT service are discussed here. User can easily and securely register, organize, monitor, and remotely manage IoT device executed with the AWS IoT device management. Moreover, can set up different administrative privileges to ensure the IoT devices are secure. The AWS IoT device management can be used with other IoT services to achieve a different goal. For example, integrate with the AWS IoT Core to enable the connecting device to the cloud and facilitate remote management and monitoring of IoT device. The next service is the AWS IoT Green Glass. AWS IoT Green Glass provides a pre-built or custom model for developers to build IoT devices rapidly. In addition, developers can program AWS IoT Green Glass to filter device data and transfer only the necessary information back to the cloud. Another advantage of AWS IoT Green Glass is that IoT devices can securely communicate with each other on a local network. The AWS IoT Analytics is a service to perform complex data analysis. Besides, AWS IoT Analytics to filter, transform, and clean the highly unstructured data. It is also available in other analytic platforms such as the Jupyter Notebook, MATLAB, or TEF to create custom analytics. The second platform is Google Cloud IoT, and it is a scalable and fully managed integrated intelligent IoT platform. This platform enables users to connect the globally distributed devices easily and securely through the protocol endpoint, and users are able to process and analyze data in real time and visualize it for a new insight. Besides, they have 2 unique features in Google Cloud IoT, which are bring AI to edge devices and use the power of Google Maps to complement the Google Cloud IoT. Next section is about the Google Cloud IoT key feature. The standard protocols supported by the Google Cloud IoT include the MQTT and HTTP protocols. Google Cloud IoT also will adhere to strict industry standard protocol to protect user business data. Besides, TLS 1.2 automatic key authentication mechanism to encrypt data transmission. There are many data analysis methods provided by the Google Cloud IoT. It includes Cloud Pub Sub for downstream analysis and Google BigQuery to query and perform real-time data analysis. The Google Data Studio also provides a rich information center to visualize the analysis result. The Cloud IoT Edge can integrate machine learning capability into the edge devices. This allows the edge device to analyze and make decisions in real time to respond to the incoming data received by sensor. It's mainly composed of 2 components, including Edge IoT Core and Edge ML. And last, the Cloud IoT Edge also uses a special hardware chips, Edge TPU, to make the edge devices have the AI feature. The last IoT platform that should be introduced is Azure IoT, and is a collection of Microsoft managed cloud services that connect, monitor, and govern billions of IoT assets. The first feature of Azure IoT is the Azure IoT Hub. Azure IoT Hub is a managed service hosted in the cloud that operates as a central messaging hub for communication between an IoT application and its linked devices and monitoring IoT application. For dealing with IoT Hub, there are 2 types of SDK, which are IoT Hub Service SDK and the IoT Hub Device SDK. Next is the IoT Central, which is an application platform as a service. It makes building, operating, and sustaining enterprise-grade IoT application easier and less expensive. Besides, this service also instantly connect device, monitor device status, define rules, and manage millions of devices. Next, the following table shows the combination of AWS IoT, Google Cloud IoT, and Azure IoT. The combination includes communication protocol, IoT core function, analytics service, edge computing, end-to-end security, and authentication. That's all for my part. Thank you.
Now I will discuss about how the IoT hardware can pass the data to the AWS IoT core and store data in images to the Amazon S3. First of all, we need to install a Node.js-based tool named Node-RED. This Node-RED will act like a IoT hardware and pass the data to the IoT core. But then we need to add on a new command, which is this command. This command will help us to install the Amazon S3 node to allow us upload images to the S3 bucket. After install the Node-RED in your PC, so we need to configure nodes as accordingly. The first node will be the timestamp. The second node will be the function. The third node will be the MQTT out. And the last node is the S3 bucket node. After we have created all the nodes accordingly, we need to create a thing inside our IoT core. Our group has created a thing named Node-RED camera. While creating the things, we need to attach a policy for it. The policy will set as the star inside here to allow the Node-RED to have the full access to the IoT core. When click on the MQTT output, you should see the server and the topic. We need to create a new server for this node. When you click inside the pencil icon, it will require you to enter the server endpoint. The server endpoint can be found inside the AWS setting. So the port will be set to 888 and 13. The TLS configuration will allow you to upload the certificate, private key, and also the CS certificate that you downloaded just now. So basically, the topic name, we just put the Node-RED test and click on done. Now we should start configuring the S3 node. But before that, we need to create an IAM role for it. Our group has created an IAM role named store data to S3 to allow the Node-RED to have the full access to the S3 bucket. When click inside the pencil icon, it will trigger you to enter the access key ID and the secret access key. This thing will be obtained when you're creating the IAM role. You should enter the bucket name that you need to store the uploaded images. And then you need to enter the file name and enter the local file name, which is the file path, and also enter the correct region, which is the US East one. After that, you should click the deploy button here. And it is successfully deployed. And we should start perform testing now. So we enter the topic name now. And click on the subscribe button. And now back to the Node-RED and click on the little square button here. And we should be able to receive the data. And now let's navigate to the S3 bucket. When click on the refresh, we should be able to receive the image. That's all for my part. Thank you.
Now we'll be performing about the configuration on image recognition and notification with AWS Lambda recognition, SNS, S3, and DynamoDB. First one, create the IAM role. We click on the create role and choose the AWS service and choose Lambda. Then press next. We attach the policies for the services as below. First one is the S3 full access. Next one is the CloudWatch full access. And then recognition full access. And last one, the DynamoDB full access. After add on the permissions, we click next. And now we give the role a name and description. And now we check on the permissions given to this role. If everything okay, then we press the create role. And now we can see the new role created just now. Next, create a new SNS topic. Navigate to the SNS service. Then click on the topics on the left-hand panel. And then press the create topic. Choose standard. And then give the topic a name. The other option remain default and press the create topic. And now you should be able to see the newly created SNS topic. From the left-hand panel, choose the subscription button. Then press on the create subscription. For the topic ARN, the topic that created earlier from the drop-down menu, next, select the protocol as email. And now, the endpoint we just key in as our teammate email to represent the police station official email address. This is to receive the email from the SNS when traffic jam is happened. The other two remain default and press the create subscription. And the email we receive, and we will need to press the confirm subscription. And this shows the confirm subscription, and we go back to the dashboard. And now the status shows confirm. This means that we will receive the email from the system. Now create a DynamoDB. And we can do the DynamoDB service, then click on the tables on the left-hand panel. Next, click on the create table button. Give the table a name called traffic status DB. And then assign timestamp as the partition key. Next, click the create table. Once the table is created, it will display in the control and status is active. That's all for the DynamoDB. Next, the Amazon S3. Go to the Amazon S3 dashboard and press on the buckets and press the create bucket. Next, give the bucket a name called traffic timer. And then press the create bucket. After the bucket is created, we will be able to see it in the dashboard. That's all for the bucket.
Hi, my name is Tanzawei. Now I would like to present about how to create an AWS Lambda to generate notification to Amazon SNS and send data to the recognition, and at the same time create data in log to the CloudWatch, and the final analyzed data will be stored in the Amazon S3 and DynamoDB. First, we need to create a Lambda. Then we create a function. We select the use a blueprint. Under the search bar, we type record. We select the recognition -Python. Then we click the configure. We should give the function name to the Lambda. The function name should be called e-record-lambda-2. We select the use and existing role for the execution role. Under the existing role, we select the recognition-from-s3. S3 trigger, we select the bucket called testing-image-record-lambda, and the event type should be same, all object create event, and we scroll down, then we create the function. Then we will navigate to the development platform. Firstly, we need to click the add trigger. We select the S3 bucket. Under the bucket, we select the testing-image-record-lambda. The event type remains the same. Then we need to click the acknowledge that add. Then we need to click the add destination for SNS. All configuration remain the same. Under the destination, we click the traffic_jam_SNS and save it. Then we scroll down to the code source and paste the code we have programmed to the development platform. Starting from the line 43, the code will be focused on analyze the image whether have traffic congestion or no traffic congestion. And the final analyzed result will store to the S3 and the DynamoDB, and will send the notification to the user by using the SNS message. Next, we will select this image as a sample to show the traffic congestion. We back to the node rate and click the button beside the timestamp to trigger the program. And we will receive the SNS message about the traffic condition of the image, and the traffic status are show the traffic congestion. The detailed log we can view in the CloudWatch. And the final analyzed data are stored in Amazon S3 and the DynamoDB. That's all for my part. Thank you.
Hi, my name is Wei Xuan, and I'll be demoing how we could pass the message to the smart traffic light. First of all, we add a delay button over here, which can be found over here, and set the delay to 8 seconds, and name it waiting traffic status result. This is added because the whole process needed time to process for the recognition, therefore we added this node. Next, we add in the Amazon S3 node and set up it as shown. First of all, we put in the bucket name, which we have created earlier. In this case, it's traffic light timer, and also the file name we want to access, which is traffic status.json. Last, we set our US region to US East 1, and this AWS. We have to put in SS key and SSID, which you can find in the IM management console over here, this access key. Next, we click update. Done. Next, we put in a function node, which you can find over here, and put in this code in order to access the JSON file and the message inside. Next, we put this MQTT broker node and we set up this server. We put in the server name, which can be found over here. The IoT manage things settings. We paste this in and change the port number to 8883, and then we use DLS. In DLS, we upload the certificate, private key, and CS certificate for the IoT things, which is named Node Smart Traffic Light. And then we click update. Update. I have to set the topic to Node Smart Traffic Light Test. Done. Next, we subscribe to the topic as shown over here, Node Smart Traffic Light Test. We subscribe. Alright, let's start. Now we wait for the uploading. Okay, the upload is done. As we can see, the process is done. Okay. The message is processed and can be sent to the smart traffic light. Also, in our email, you can see the result of the traffic light changes. That's all. Thank you.